Hello class, Professor Anderson here. Let's take a look at an example problem. This is one that we already talked about, but let's take a look at it again with this idea of breaking the vectors into components in terms of these unit vectors and then adding them up as vectors. Okay, so let's review our picture. We're going to run 1 mile to the north, then 0.4 miles west, and then 0.1 mile south. Okay, so our first leg of our journey is straight up, 1 mile. And then we go 0.4 miles to the west, and then we go 0.1 miles south. And we want to figure out this guy right here. What is that R vector? Once you identify the vector, you know everything about it. Okay, you know the length and you can calculate the angle. So all we need is the vector. And let's label these A, B, and C. And let's figure out how to write these things in terms of the unit vectors that we just talked about. Okay? So this one, this first leg, that's vector A. How do I write that as a vector in this XY coordinate space? I need something multiplying I hat, and then I need something multiplying J hat. I hat is in the X direction. Okay? In this case, it would be along the east axis. So what do I put there? What should I put there? Yeah?
0.
0. Right? This first one doesn't go any in the east. Okay? What do I need to put on the second term? 1. Right? 1 mile. So this is how I write that first vector. It's 0 I hat plus 1 j hat. The second vector, B, is going to be what? Well, we've got something in front of the I hat. We have something in front of the j hat. What do you think? Yeah?
I'm confused as where did the 0 come from?
Okay. Good question. So this east axis is what we're going to say is our typical x-axis, which means that I hat points along that axis. Okay? So for the first vector, vector A, was it going at all in the I hat direction? It was going exactly 0 in the I hat direction. Okay? So we don't technically have to write that. We can just cross it out entirely, but we're trying to be clear here. All right. And of course, it went 1 in the other direction, 1 mile in the other direction, which is j hat. What about B? Let's do the easy part first. What should I put there on the j hat for vector B? How far north is it going? Was that a okay, or was that a 0?
Yeah.
That was a 0? Okay. That's a 0, right? Vector B is going perfectly west. It's not going at all north. What do I put on the first one? You're itching to raise your hand and shout something out. Go for it.
Well, it should be 0.4, but I don't know if it's negative. Is it supposed to be negative? It's
All right.
supposed to be a
Let's do the easy part first. 0.4. And now the question, is it positive or is it negative? All right. When you are moving along the x-axis, it's positive. If I'm moving along the negative x-axis, then it is negative. So is that thing moving to the right or to the left? It's moving to the left, and so we want to make this negative. Good. All right, almost there. Finally, we got to do vector C. What is vector C? Well, we know that it's not moving in the east or west. So that first term is 0. And now, based on what we just did, what should I put there? You guys know the answer to this. It's negative 0.1. Okay. All right. Those are our 3 vectors written out in this component form. And now it's nearly trivial to write the resultant vector. How do I do it? I add these up. All the I-hats I add up. I add 0 to negative 0.4 to 0, and of course I get negative 0.4. And now I add up these three. I have 1 plus 0 plus negative 0.1, and that gives me a positive 0.9 j hat. And now you're essentially done. Once you know the vector, you essentially know everything about the vector, right? Calculating the magnitude is just a matter of squaring the first term, squaring the second term, and taking the square root. And we already did this. We know what the answer is. It's 0.98. And if you want to figure out, say, this angle right here, phi, how do we do that? Well, let's draw the triangle, phi. This is 0.98, which we said was r. This was 0.9, which that's going to be our r sub y. And this is our r sub x, which was negative 0.4. Okay, those are the three sides of our triangle. This is, again, a right angle. And so phi, you can do any trig relation you like, but let's take the arc cosine of 0.9 over 0.98. And if I remember right, I think we got 23 degrees. Okay? Any questions about this one? Any questions about how we approached it with the unit vectors? Okay, good. Hopefully that one is clear. If not, come see me in office hours. Cheers.